Solutions. Solutions are homogeneous mixtures. That means they have the same composition throughout. They can be made using solids, liquids, or gases, or some combination of the two, of the three. The solutions are uniform all the way throughout, and you cannot separate them by filtration. If you take a solution, like for instance, sodium chloride and water, salt water, and you pour it through filter paper, it will not separate that solution. In order to separate it, you're going to need to use chromatography or distillation. And we will talk about those two techniques tomorrow. Quite a few of you have already done a chromatography lab and you have seen a distillation setup before. We'll talk more about exactly how the chromatography works tomorrow. And then you're going to have some work to do with your chromatograms that you made when you were here in person. Now, molarity is how we're going to calculate the properties of a solution quantitatively. And molarity is moles of solute per liter of solution. So your numerator is moles, your denominator is liters. Molarity is abbreviated with a capital italicized M, or when you write it out by hand, you write an M and you underline it because, it's hard to write in italics when you're printing something. The thing about molarity is it will vary with temperature. Typically, to make a solution of a specified molarity, you will take the solute and you will put it in a volumetric flask and you'll fill it up to the little fill line in the neck of the flask. However, since water will expand and contract with temperature, if the temperature goes up, the volume of the solution goes up, and if it goes down, the volume of the solution would decrease. So the molarity actually varies with temperature. So typically, these things are specified as taking place at 25 degrees Celsius, which is room temperature, although it's a little on the warm side for room temperature. Also, when you're making a solution of a specified molarity, if you're trying to make 2 liters of a 1 molar solution, well, you would take 2 moles of solute and you would dissolve it in solvent so that your total volume is 2 liters. You do not add 2 liters of water to the solute because then your total volume would be greater than 2 liters. So you have to be careful with how you actually do this. And we'll be doing some labs where we will actually make solutions. So we're going to get into distillation and chromatography tomorrow. So let's take a look at a problem. If 38 grams of calcium chloride are dissolved to make 750 milliliters of solution, what is the molarity? Well, molarity equals moles over liters. 750 milliliters is 0.750 liters. You divide by 1,000. Then to find moles, we need to take our 38 grams of calcium chloride and convert those grams into moles, where 1 mole equals the mass of calcium plus the mass of chlorine times 2, which is 110.98. So we take 38 divided by 110.98, which is 0.342 moles. And so we take 0.342 moles divided by 0.750 liters, and I'm getting 0.4. Let me make this look a little more. 0.456 molarity. Now, what's interesting about this is when calcium chloride dissolves, it will dissolve to make calcium ions plus 2 chloride ions. So the molarity in solution of calcium ions is going to be 0.456 molar, because for every calcium chloride you get a calcium ion. The molarity of chloride ions would be 0.912 molar, because for every calcium chloride you get 2 chlorides. Now, I want to show you an additional step to this problem we could take. Down here, I ask if the solution, the one we made up here, is diluted to 3 liters, what is the new molarity? Well, there are 2 ways you could calculate this. Because if we're diluting it, we're adding water, we have not changed how many moles we have. So the molarity would equal 0.342 moles divided by 3 liters, which would be 0.114 molar. Or we could use an equation that, since moles stay constant in both of these cases, we can kind of create the equation. It was on your honors chemistry reference tables. It says M1V1 equals M2V2. So the initial molarity times the initial volume equals the new molarity times the new volume. Because since molarity equals moles over liters, molarity times volume equals moles, and moles stay constant. So our initial molarity was 0.456, and we had 0.750 liters, and that equals our new molarity times our new volume, where molarity number 2, we 0.456 times 0.750 divided by 3. Lo and behold, it comes out to be 0.114 molar. If you did not know how many moles you had in your initial solution, this would be a more direct way of finding this out if you were just given a solution and diluting.